Okay, this is the best I can do, I think. Okay, so this is version A for quiz 4. This is also number 2 on version B. So first step in the process, we want to write the givens. Okay, so here we have 2 givens. S is the midpoint of QR, and PS is perpendicular to QR. So we have our steps and our justifications. Okay, first step in the process is to write our given. So S is the midpoint of QR, and PS is perpendicular to QR, and those are given to us. So those are given. Okay, the second step is to look for shared sides or vertical angles. Okay, and if we notice, we do have a shared side. SP is part of both triangles. Okay, so we have SP is congruent to SP. That is the reflexive property of congruence. So reflexive property of congruence, but you don't need to write of congruence. We can just leave it at reflexive property. Okay. No vertical angle, so we can move on to the third step in the process, which is to use the givens. Okay, again, we're looking for 3 pairs of congruent sides and or angles. We have 1. Okay, but we have 2 givens that we can use. The first is the midpoint. Again, if you look at your reference sheet, definition of a midpoint is a point that divides the segment into 2 congruent pieces. So S is going to divide the segment RQ into 2 congruent sections. So RS is congruent to QS. Okay, and that is definition of a midpoint. Okay, on the reference sheet, if you read the definition, it says a midpoint is a point that splits the segment into 2 congruent segments. So we take RQ and we split it. S splits it in half. It splits into 2 congruent segments. This is following directly from the definition. Okay, if we also put in our SP is congruent to SP, we now have 2 congruent parts. We need to find a third congruent part. Luckily, we have another given. So we're going to use our other given. If you have parallel or perpendicular lines, you are looking for right angles. So we know that angle RSP and angle QSP are right angles. The definition of perpendicular lines tells us that perpendicular lines form right angles. So where these 2 lines intersect, PS and QR, where they intersect, they form right angles. So angle RSP and angle QSP are right angles. And again, that is the definition of perpendicular lines. Definition of perpendicular lines. Again, the symbol, the upside down T, means perpendicular. Okay, once we know that 2 angles are right angles, we can say that they are congruent. Angle RSP is congruent to angle QSP because of the right angle theorem. Right, our right angle theorem says that right angles are congruent. Simple as that. Right angles are congruent. So if we have 2 right angles, right, and step 5 tells us that angle RSP and angle QSP are right angles. So we know that they are going to be congruent because all right angles are congruent. Okay. We now have 3 pairs of congruent sides and or angles. If we look, again, we cover 1 triangle up. Okay, and we just want to look at 1 triangle. This is the side or an angle. This is a side. Is this a side or an angle? This is an angle. Is this a side or an angle? It is a side. So we want to go in order. Side, angle, side. Okay. So side, angle, side. And the side, angle, side postulate tells us if you have two sides that are congruent and the included angle is congruent, then the triangles are congruent. So triangle, and this is what we're trying to prove. This is not a given. This is what we're trying to prove. PRS is congruent to triangle PQS. Okay, triangle PRS is congruent to triangle PQS. So we know these two triangles are congruent. They are the same size and shape because we know if we have two sides that are congruent and an included angle that's congruent, we know they are congruent. So that tells us these two triangles are the same size and shape. That is number 1 for version A.